Welcome. This is design of shear reinforcement for beams in the form of vertical stirrups by limit state method. This class I will give procedure. This is part 1. Part 2 will be numerical examples. Then next will be shear reinforcement in the form of vertical stirrups when cranked bars or inclined bars are also present. Then after procedure, next numericals. Just 4 sessions. See, note. Long back, maybe around 1.5 months earlier I think, you can see there. RCC class 32, A, B, C, D. 4 parts, same thing I uploaded. But at that time, it was working stress method. Now this is limit state method. So limit state method is more important because at present we design by limit state. But if you remember, I told at that time, see, flexural analysis, working stress method, limit state method, lot of difference is there. But design of shear reinforcement is identical. Only change is their service load values, here factored values. One extra suffix u will be considered here. Even then, I will give systematic procedure. Actually, what I have done is, see, what I have done for writing all these is, I will tell you, my old class, I took photograph of the class. I maintained same sequence so that suppose you require some clarification, you can go back to that class. So here, I will minimize the statements all, give more important to numericals and procedure. At that time, I told so many things. Even some money matter also told to understand when shear reinforcement is required or when you have to redesign the cross section, that also told. Maybe I will tell here also, but I cannot remember exactly what example I given at that time. I will tell something and forget it. I will invent a new one now, here. Okay, start, first step. One more thing. All this IS code is class number, not class number, class 40, page 72. Everything is there. You start from this page 72, everything will be there. Limit state method, remember? Okay, now, data. To design shear reinforcement in the form of vertical stirrups for a beam, what data you require? Width of beam B, effective depth D, AST provided for cross-section considered. This I told at that time. See, along the length of the beam, AST may not be same. Sometimes some of the bars may be curtailed or cranked. Suppose in the mid-span, you provide some 4 bars, simply support beam, 4 bars. When you come near support, bending moment will reduce. Therefore, maybe of the 4 bars, 2 bars will be curtailed, stopped. Remaining 2 will be continued to support. Design of shear reinforcement usually done for maximum shear force. Maximum shear force will be at support. So when you consider cross section at support, mid-span provided 4 bars will not be there. Only 2 bars will be there. That you require. AST provided for cross-section considered. More and more I told in working stress method. Remember, here I am giving data. But when you do practical design, see, after deciding arrangement of steel, you will be knowing which section you consider for design of shear reinforcement, that cross-section, what is the available tension reinforcement there will be known for you. Okay, then grade of concrete and steel. Then and also remember limit state method, factored shear force for cross section considered. This you know it. In case shear force is given corresponding to working load, you have to factor it. Okay, by multiplying by gamma f in absence of data 1.5. Okay, start. Step by step procedure. See, what are all notes I have put in a box. This box is only for understanding purpose. Procedure point of view, main writing. See, this is procedure. Then here, This box is only to understand. Okay, now start. See, wherever I write IS code means, see, if I write IS code, it means, IS means this, see, this expression is available in the IS code. You don't have to by heart it. First find nominal shear stress for cross section, that is tau V equal to VU by BD. Shear force VU divided by B into D, force by area. Now, one important concept I told, in working stress also I told. IS code used the word nominal. I don't agree with them. Anyway, I won't pass any bad comment. But this word is not correct, I feel. Because when you tell nominal, what comes to mind? Namesake. See, class. Here, nominal does not mean namesake. See, usually, provide nominal means what? Just namesake, some little minimum that way. No. By chance they use the word. Therefore, you just, the word nominal, even if used, you don't worry too much about it. Or, remember, here nominal does not mean namesake. Tau V is the shear stress due to factored shear force VU. See, right there. See, I told, further in the class I am dictating. When you, due to shearing force, how much shear stress, that is tau V. So, very, very important. And cross section should be able to resist it. Okay. Or later, I will give example for you. Tau V, I will tell you, today you have gone to a restaurant and you took the food. Bill will come. How much bill you have to pay? See, how much factored shear force cross section has to resist. Due to that, tau V, how much shear stress cross section has to resist. So equal to or equivalent to how much money you have to pay. You have to pay how much is the bill amount. Therefore, you have to pay the bill amount. Or I told, cross section should be able to resist it. So do not worry about the word nominal. So now remember, tau V is the actual stress. Cross section should be able to resist it. Okay. Now, next, referring to IS code, table number 20, page number 73, I need not give. Get tau C max based on grade of concrete. See IS code. For a different concrete, M20, M25, etc., they given tau C max values. Now, this tau C maximum I already told in working stress method. It is tau C max is the maximum limit for tau V. See, the shear stress tau V at any cost should not exceed tau C maximum. See, maximum limit for speed means what? You should never drive at a speed more than that limit. Okay. Even with shear reinforcement means even after providing shear reinforcement also, IS code does not want the shear stress to exceed tau C maximum. There is reason for it. Logic is there, reason is there. That all here I will not tell because I can't discuss all the concept here. This is I am giving procedure for design of shear reinforcement. Maximum possible concept I will give within the some timeline. Okay, therefore, tau C max based on grade. Now see, tau C max is maximum limit for tau V even with shear reinforcement, or what IS code told is under no circumstances, see, under no circumstances, even with shear reinforcement shall tau V exceed tau C max, means tau V should not exceed tau C maximum. Therefore, we have to ensure tau V more than tau C, we have to ensure for safety, tau V should not exceed tau C maximum. Okay. Now, next step I will tell. 1 minute now. I will make everything clear once again. And this I will remove now. One information. Next step, I will write here only. Compare whatever tau V you got with the danger number. See, tau C max is the danger number. See, now I told you these all statement I wrote Exactly by seeing photo, because that is written by me only, it is not copying. What I wrote for working stress method, I took the photo. In the photo, this also is there. I don't require. Maybe little this side, that side, what is there? Not that I'm going to copy. So just because I use the photo up to here, does not mean that I for that matter, I do not require photo. Okay. Tau C with tau C maximum. Okay, now, I will write here. Compare tau V with tau C maximum. Okay, see. Case 1. I would put case 1 actually. Okay, no, okay, I don't know whether I'll check that one. Case 1 is there or not there. Only for that purpose. No, case 1 is not there. Case comes later. Okay. Now, compare tau V with tau C max. See, this is, you can make a note here, shear stress to be resisted. I should not give. Actually, just to understand, tau C maximum is what? Maximum limit for shear stress even with shear reinforcement. Even if you provide shear reinforcement, limit. So compare tau C maximum. Now, for safety, tau V should not exceed tau C maximum. Tau V should not exceed tau C maximum, right? Therefore, safety. Therefore, in case tau V exceeds tau C maximum, means the shear stress is beyond the limit. I told you cross section should be redesigned. So that after redesign, tau V is not more than tau C maximum. Okay, over. Okay, now this is tau V should not exceed tau C maximum. So if tau V exceeds tau C maximum, our procedure stops here. You cannot continue. What do you have to do? You have to redesign the cross section. Okay, now continue. Now continue. Not coming. Okay. Continue. That is, if we get tau V not more than tau C maximum. So you proceed further. You can write that. Maybe there I don't written something else. If tau V is not more than tau C maximum, continue. I continue. Or you can tell that is safe. This is I can write here. If tau V exceeds tau C maximum, that is not safe. It is not safe. Okay. Now I will continue. So I am continuing when tau V is not more than tau C maximum, or tau V is either equal or less than tau C maximum. I will continue. Okay. Now, before proceeding further, one extra note you can make. It's complete note, remember. It's only a note, not procedure. See. Right here. In case tau V comes more than tau C maximum. If you do manual design, you have to redesign. In that case, in ETAP software, red color, you can see O by S. So whenever you see O by S in red color in ETAPs, it means cross section is inadequate. You have to redesign. Those who are knowing ETAPs will be knowing it. Okay, then one extra note you can write. Just now I told, see, what? See, just now told, what? You write here, just now told, compare tau v with the tau c maximum. And proceed further, only if you should write, if you are serious, you should write. Just now he told, he means me, compare tau v with the tau c maximum. Tau v should not exceed tau c maximum. If it exceeds, cross section to be redesigned. Now, continue further if tau v does not exceed tau c maximum. Now, one note. Comparing tau v with tau c maximum is only a check for safety or to ensure cross section provided is okay based on shear. Based on shear. Based on shear. That is, you can write, it is a permission to proceed further. This comparison this comparison will allow you to proceed further if tau v comes not more than tau c max. Now, this comparison, which one? Tau v with the tau c maximum will not decide whether shear reinforcement is required or not. This step will not, this is only a safety check. This will not indicate or decide whether shear reinforcement is required or not. Somebody will ask, sir, when it will come? Okay. Now see, new sentence, or not, full stop. Then see, capital letter, whether shear reinforcement is required or not will be decided, some siren is going on there, okay, will be decided only after we compare tau v with the tau c. So whether shear reinforcement is required or not, you will be knowing this is only a safety check. You will be knowing it after you compare tau v with tau c. Tau c will come next. See, you can see there, tau c is coming there. Okay. Make a note. Okay, now cancel. Write if you want. Okay, now further procedure. These are all note only. Don't write in procedure. Write somewhere outside. Procedure, write compact form, how much required. That is further procedure. That is after ensuring tau v not more than tau c maximum. Okay. Get tau c. Tau c means allowed shear stress for concrete alone without shear reinforcement. That means only concrete. No help from shear reinforcement. How much shear stress concrete alone can resist. This is all I told working stress method. Now, IS code told design shear strength of concrete. They told shear strength of concrete. They told there without shear reinforcement. Without shear reinforcement, but stress based. That is strength actually sometime for force also use. This is stress based. Okay. Now, how to get tau c? Refer IS code table 19, for which we need PT provided. That is percentage of tension reinforcement provided for the cross section considered. You already know AST provided. So PT provided equal to 100 into AST provided divided by BD. After finding PT provided, refer table 19, get the value of tau c. Note, grade of concrete also to be observed, because in the table you can see M15, M20, M25, refer whichever is the concrete grade. Okay, now, intermediate values can be obtained by linear interpolation. Okay, now, I told this is step over to get tau c. Now, procedure, I will continue. Continue. Make a note now. When I continue procedure, you know the value of tau v and also you know the value of tau c. Tau c maximum already, which tau c maximum will vanish. Once it is safe, tau c max will vanish. Okay, now you already know how much is the shear stress to be resisted, how much shear stress concrete alone can resist. Both are over. Okay, I'll start here. Full I will remove now. Last part now. Okay. I will tell the order. Don't write immediately. See. Compare tau v with tau c. Now, only for understanding, this is not wrong. Cut it, because don't write in the procedure. Write outside or write light line so that you don't have to write all these things while solving the question. tau V, shear stress to be resisted by cross section. Tau C, how much shear stress concrete alone can resist. How much shear stress concrete alone can resist. This only will tell you if tau V is less than or equal tau C, shear reinforcement is not required. If the shear stress exceeds the limit for concrete, then you require shear reinforcement. This only will tell. Still, I told example in working stress method. I do not remember what I told. I will tell you. See, example now only. Outside, write somewhere outside. Imagine, you write, you are concrete. You are concrete. You have Indian rupee 100 rupees, sufficient 100 rupees. This is your tau C. Tau C. How much shear stress concrete alone can resist? How much money you alone can pay? How you have 100 rupees. Remember, no credit card, no debit card, no what you call electronic transfer. Olden days. Imagine 30 years earlier. Now people will tell, sir, we'll make a payment by phone. No, phone pay, nothing allowed. Understand the exam. You don't have any electronic facility, only cash. Okay. Or you have gone to a restaurant for eating. He does not accept electronic transfers. You have 100 rupees. This 100 rupees is tau C. How much shear stress concrete alone can resist. How much money you alone can pay without anybody's help. Now, do one thing. Imagine in the restaurant, you know one person. Your friend is also working there, maybe manager. The manager, your friend is in the restaurant. He told you, if requirement is there, he told you, I can give you 200 rupees. He told, I can give you, if requirement is there, he told, I can give you 200 rupees, maximum. That's all he has got. 20 years earlier, not now. So this is not tau C maximum. Now see, first, tau V is the bill. Tau V is the bill. What is tau V? That is shear stress to be resisted. That is bill you have to pay. 1 minute now. Tell me, one by one case. First, imagine tau V is bill, or imagine bill is 80 rupees. Now doubt comes, what is the tau C maximum? Okay, I'll write, what is the tau C maximum? Where is red color pen? I kept it somewhere, red color pen, now not available. Here, not here, see, in time now not getting it. Here, yes, okay. Now remember, you have 100 rupees. This is not tau C maximum. Therefore, tau C maximum is how much you can pay even after taking help from friend. That is how much shear stress that can be resisted even after providing shear reinforcement. So your friend is shear reinforcement. See, your friend is shear reinforcement. So answer is how much? 300 rupees. Why? See, danger number. That is 300. Why means common sense. 300 rupees. See, you have 100 rupees. Your friend is shear reinforcement. See, extra help. Shear reinforcement is what? When concrete cannot resist alone, shear reinforcement will help it. When you have difficulty for paying the bill, your friend will help. So after taking your friend's help, you have 100, he can give you 200, maximum you can pay is 300. So suppose your bill, first you check it. If the bill comes more than 300, that is, see, suppose 1 minute, first bill is, suppose imagine, bill is 450 rupees. Oh, gone case. Gone case. Why? 450 rupees is tau V more than tau C maximum. See, tau V, bill 450. 450. Even after taking help from your friend, you can pay maximum 300. Therefore, redesign. Something you have to do. Request the hotel owner, sir, I don't have money, then remove the watch or put a mobile there. 30 years earlier, mobile was not there. Do what, make some arrangement, something you have to do. You are in problem. In RCC, cross-section to be redesigned means what? Here. Some rearrangement required. Okay, that is one case. Okay, I remove that one. That case I will remove now. Which case? When tau V is more than tau C. Right time not getting that rubbing part. Here. Oh, now. Next case. Now, bill came. Bill came. Imagine bill is 80 rupees. Tau V, 80 rupees. Oh, it is less than tau C. You have 100 rupees with you. See, tau V less than tau C. Shear stress to be resisted is less than how much shear stress concrete alone can resist. The bill came less than how much money you can easily pay yourself only. Therefore, shear reinforcement is not required in RCC, in structural part. Here, help from friend is not required. That's all. Over. Case 2. Suppose bill comes to 180 rupees. Compare, which is more than 100 rupees. Oh, shear stress is, tau V is more than tau C. Second case. Shear stress to be resisted will come more than capacity of concrete. Bill came 180, you have only 100, so help required from the friend. How much help required? Not 180 rupees, 80 rupees. That's why later we will write shear force to be resisted by stirrup equal to shear force Vu minus shear strength of concrete. See, 180 rupees, subtract how much money you have got. From 180, subtract 100. 80 rupees, you take help from your friend. Here, from the shear force, subtract how much shear force concrete alone can resist. Balance, you provide steel. Okay, now, hope everything is clear. Right here. No money, nothing now. See, now, tau V less than tau C or equal tau C means shear reinforcement is not required to be designed. Provide nominal shear reinforcement or minimum shear reinforcement. See, there you don't take money, but here you have to provide nominal stirrups. So what you do is, in India, usually we provide two-legged 8-tor vertical stirrups. Any building you see in India, whether shear reinforcement is required or not required, the stirrups will be always minimum. They use two-legged 8-tor, long back 6 mm diameter. Now 6 tor is not available, it is 8-tor. And remember, no calculation of spacing. No calculation of spacing based on strength. Based on strength, no calculation. Therefore, now doubt comes. See, one stirrup you provide here, next you provide here. Okay, I'll put a sketch here, top bar, bottom bar. Okay. What is the spacing you have to give? Spacing. See, shear reinforcement is not required. So, therefore, you should not waste the steel. You provide as much more as possible. Why? Because if you provide closer, waste of steel. But remember, IS code has got a limit. Therefore, no calculation. Provide at a maximum permissible spacing as per IS code. Come here. Immediately come here. As per IS code, maximum permissible spacing for vertical stirrups is 1, 300 millimeter. 2, search IS code, you will get it. 0.75D. 3, ASV into 0.87 FY by 0.4B. ASV is cross-sectional area of legs of stirrups, and IS code told FY is not to be taken more than 415. This all I told earlier in working stress. Anyway, when I do numerical, I will explain once again. Okay. Substituting, get all three values. First value not substitute, directly 300. Then after getting all the three values, see, it is a maximum limit. So remember now, I should not tell whichever is least. Whichever is least. So after getting all the three values, consider the least value as of them as maximum spacing and provide. And provide. Which one? Provide shear reinforcement. Provide and provide. Okay, and provide. Over. This is the case when tau v is either equal or less than tau c, or when the bill comes either equal to 100 or less than 100. Now last case, see, practically when you design, more than 90% times bill will come more than 100. That is, tau v will come more than tau c, so shear reinforcement is required. So now the most important, case 1 over, I will go to case 2. See, when I start next I write case 2, tau v more than tau c. Okay, I will start next last part. Okay, now come to case 2, tau v more than tau c. That is, if you want, you can write as a note, shear stress to be resisted by cross section. How much shear stress concrete alone can resist, or your money matter, bill more than the money in your pocket. So help required. Therefore, shear reinforcement is required to be designed. You have to design now. Here we are providing shear reinforcement in the form of vertical stirrups. You can see title there. After this completely over, I will tell what to do if inclined bars are there, second round. That is class number 3 and 4. Decide number of legs and diameter of the stirrup. Okay, this all I will explain in the numericals. What diameter is considered, how many legs are considered, I will explain the numericals. Then we have to find spacing. The spacing of vertical stirrups, SV equal to 0.87 Fy ASVD by VUS. Working stress method, sigma SV ASVD by VS. Okay. ASV is cross-sectional area of legs of stirrups equal to pi by 4 diameter square into number of legs. High school student will understand. VUS is ultimate or factored shear force to be resisted by vertical stirrups. See, our shear force is VU, factored. From VU, you have to subtract how much shear force concrete alone can resist. This also I explained. So VUS equal to VU minus VUC. VUC is ultimate shear strength of concrete, or how much factored shear force concrete alone can resist, equal to tau c into BD, allowed stress into area. Therefore, see, substituting, get VUC and then get VUS. Actually, IS code has not given this way. They told directly VUS equal to VU minus tau c BD. But I am doing this way for some reason. I will let you know later. Anyway, this becomes more clear. Okay. Now, one condition. IS code told the value of Fy is not to be taken more than 415 Newton per mm square. Reason I told in the regular class. So if Fy is less than 415 or equal to 415, take 415, write it there. But in case you are using Fe 500 steel, for shear reinforcement, you should take 415 only. Numericals, I will explain. Substituting, get spacing SV. Now very important, this spacing is based on strength. See, once again note, this SV we get is based on strength. So what spacing comes, you should be careful. Whatever shear steel comes here, you should provide either equal or more. Providing more shear reinforcement means what? Bring the stirrups closer. Remember, spacing it is. See, number of bar means you go for next number, higher number. Spacing means you have to reduce it. If you increase the spacing, it becomes weaker or based on strength. So later, we should provide stirrups at a spacing of either this calculated value, where is it here? Either this calculated value or less, not more, or less. Class. Reason I told. If you see whatever space, suppose the spacing comes, for example, 143 mm. If you provide 143 mm, not possible. Round off, say 140. 150 you can't make. If you increase the spacing, it becomes weaker. See, stirrups will go further away. Therefore, either equal to calculated or lesser. Now, now what you got? Now you got the spacing. Now, before providing the spacing, consider IS code. See, that's why I have not rubbed it. From here, directly go here. IS code. This already I explained for you. But one thing now you need not explain this one. Why? Because ASV already came here. Last time it did not come, so I wrote there. So you know everything. Same condition here. Substituting at the three values, the least value is as the least value of them as maximum per spacing. No provides. Now, very important. See, we got. You can make a note here. We got two values of spacing. One based on strength, other based on IS code. Which one to provide? ISC. Suppose imagine this spacing comes to 143. IS code will tell you cannot give more than 250. Then provide 143 only. Why? IS code told you should not provide spacing more than 250. Why? It is the maximum limit. But by chance, if the shear force is very less, this spacing can come 545. Then even strength requirement is 545. But IS code told you cannot give more than 250, provide 250. Or remember, two values are there. Therefore, compare spacing based on strength. That is SV calculated. See here, that is this value. See, this value. Compare spacing based on strength with maximum permissible spacing. No space right here. Maximum permissible spacing as per IS code. And provide least value. Over. And remember, when the question of rounding off comes, round off lesser side, not higher side. See, number of bars rounding off is higher side. In beam shear reinforcement or slab spacing round off is lesser side. Okay. Now, over. This is our part 1. What I consider is part 1 procedure. Immediately, within one day, you will get part 2. Numerical example. 3 problems I will do. One problem, tau E will come more than tau C maximum. Unsafe. Second problem, tau E will come less than tau C. Shear reinforcement not required. Third question, most important, 90% chance practically or even academically also. Tau E comes more than tau C. We will design shear reinforcement and close that one. Then part 3 and 4 will be for shear reinforcement, design of shear reinforcement when inclined or cranked bars are available for resisting shear. I will complete everything so that 3 more parts. After that one, I will upload last in the series here, analysis of T section, how to find ultimate MR for T section. Then after that one, I am changing my complete program. I will let you know everything after I upload T-beams. I will tell at that time, all my previous classes are now not deleted, goes backwards. I am telling, fresh I am starting with a new way of teaching also, not this way. Not that this is bad teaching, I have decided to completely go new. Starting from engineering mechanics, systematically classes will be started. Not like a class, a part of the class here or a part of the class there. No. Systematic means systematic. How many classes are, I will let you know later. And one more thing. See, this money matters all. Don't think I require it. I know students get confusion. Somebody can tell. He talks about money matter all in the structures, no standard. Let them come in front of me. I will ask rapid, or I will tell them, go and see my special updating there. One series of classes I am updating where technical points are considered, where maximum people make mistake. I told already. If they go through that one, then they will realize, oh, he is telling all these things for our benefit. Not that he require. I do not require any money matter example. When I tell tau me more than tau he, it comes to mind. Correctly, it comes to mind. Okay. Now, thank you. We will meet next time.